Hello everyone. Today we will start our last unit, that is the construction and working of some other meters. Already we have studied the various construction and working of power, energy, resistance, inductance, capacitance measurements, etc. Now the another very important parameter in our life, that is power factor. So the next topic is power factor meter. Already whatever we have studied or whatever we are doing in our life, that is in the for the circuits we are using the wattmeter, voltmeter and ammeter to determine the power factor. So try to understand what is power factor. Basically we know the power factor is the cosine of the angle between voltage and current. Power factor is the angle, cosine of the angle between voltage and current. Also, we can have various equations for the power factor, which is directly implied by cos phi. And the power for the AC circuit, the consumption of power for the AC circuit, it is given by VI cos phi, right? The power for the AC circuit is given by VI cos phi. So, for a circuit, if we know the amount of voltage by using a voltmeter, the amount of current by using an ammeter, and the total power consumed, that is VI cos phi. So W, that is W equals to VI cos phi. So if I know the V, if I know the I, and if I know the VI cos phi, so then just we already know that if we divide that things, so we can get the power factor, that is VI cos phi. If it is divided by VI, then we can get the cos phi. Clear? That is already we understand W equals to VI cos phi. And now if that W is divided by V and I, that is the voltage and current, then we can easily get the value of power factor. But for that calculation takes some time, as well as error may be there. Try to understand. This is okay, just assume that this is the calculation will be right. But when there is a continuous change of power factor, or when there is a continuous change of load, when there is a continuous change of energy or power consumed, that is in that transient or the changing conditions, when the power or the load or the power absorption, that is W, is continuously changing, or any of the parameter, like suppose your V, your I, your W, if anything is continuously changing, then this calculation takes much time. So for that purpose, you need to focus on the specific meter, which is known as power factor meter. Here, now you will understand the construction and working of power factor meter. So before going to the power factor meter, there are mainly two type of power factor meter. First one is dynamometer type, that is electrodynamometer type power factor meter, and the another one is moving iron type power factor meter. Also, we need to measure the power factor of a single phase connection. It may be also three phase connection. So for that purpose, we need to calculate, do work with single phase and three phase. Clear? So first of all, we will understand the working and construction of single phase power factor meter. Clear? Now, just look back the definition of power factor. The power factor meter measures the power factor of a transmission system or any circuit. Here, the power factor meter determines the type of load using on the line, and it also calculates the losses occur on it. Here, so the power factor has a very important effect. By calculating the angle between the voltage and current, we can also measure the loss. Now, focus on the construction of a single phase power factor meter. This is the circuit diagram of a single phase power factor meter. And this is the, most importantly, this is the dynamometer type or the electrodynamometer type power factor meter. So just try to remember the working of a dynamometer type instrument. Dynamometer type instrument always works on the principle that when there is a current carrying conductor placed in a magnetic field. Clear? Try to remember. When we are placing a current carrying conductor in a magnetic field, we can have a torque on the conductor, or we can have a force on that conductor. So here also we are having some magnets and a current carrying conductor also. So try to understand. In the series, we are having, just focus on the cursor, we are having some fixed coil. So this fixed coil is in series, which is directly divided in two parts, which is known as current coil. Here, this fixed coil or current coil, try to understand. Here, it is divided into two parts. Here, this part, okay, and finally it will go into the load. So the current carrying coil is divided in a two part to create the magnets of the circuit. Here, so this is known as fixed coil, which is current carrying coil and which is divided into two parts. Now the potential coil. The potential coil is also divided into two parts. Here we are taking the potential coil, means power. We need to know the power. That's why we have a current coil and the potential coil. Current coil is divided into two parts, and which is known as fixed coil also. And the potential coil also divided into two parts. See, one is A. First part is connected with A and the second part is connected with B. Now, with the A, it is a high resistance is connected with this connection. A resistive circuit is connected with the circuit A, and a high inductor is connected with the line B, which is perpendicular to each other. Okay, this A and B is perpendicular to each other. So focus on the construction of the power factor meter. The meter has fixed coil which acts as a current coil. This coil is split into two parts and carry the current under test. The magnetic field of the coil is directly proportional to the current through the coil. Okay, the meter has two identical pressure coils, A and B. Both the coils are pivoted on the spindle. A pressure coil A has no inductive resistance connected in the series with the circuit. Clear? Here, the A coil is connecting having the resistive circuit. No inductance is connected. And the coil B has highly inductive coil connected in series with the circuit. The current in the coil A is in phase with the circuit, while the current coil B lagged by the voltage nearly equal to 90 degree. Try to now here is the working. The current already when it is in resistance, so the voltage of the coil A resistance should be at in the same phase, but the voltage across this terminal B, voltage across the resistance B, inductance B, it will be 90 degree lag. Clear? The connection of the moving coil is made through the silver and gold ligaments which minimize the controlling torque of the moving system. The meter has two deflecting torques. Now the principle. The meter has two deflecting torques, one acting on the coil A and the other acting on the coil B. The windings are so arranged, but they are opposite in direction. The pointer is in the equilibrium when the torque are equal. So depending upon your load, the pointer will move here. Here. So we are having a purely resistive coil which should be in phase with the voltage, and having a purely inductive line which will be again having the 90 degree lag by the voltage. And due to the action, there will be a interaction of the force on the conductor A and B and how much torque is generated, that torque will be varying from this power factor. Either it will lead or it will lag. Here, depending upon that factor, the pointer will move and show you the direction of the moving pointer. Here, so most importantly, you can get the MCQs from here. That is, the fixed coil is divided into two parts. The potential coil also divided into two parts, which is 90-degree apart. Very importantly, which is 90-degree apart from each other. And obviously, one is having resistive coil, purely resistive, and another one is purely inductive. So there is a phase difference also. And depending upon the phase difference, the pointer will move accordingly. Here, when the load is connected. Here, when the load is there, the fixed coils will be magnetized and some amount of current will be flowing to the A and B. Due to interaction of the torque between A and B, a torque will be generated, and then, which is a moving coil, then the pointer will move. Yeah. So this is the working and construction of the power factor meter, single phase electrodynamometer type power factor meter. We will do the working and construction of a three-phase electrodynamometer type power factor meter also.